Hello, welcome to the video. Today we're going to be looking at section 1.1 where we're going to cover points, lines, and planes. So throughout these lessons, we are going to be asked an essential question. In this essential question, they're asking us, how can you use geometry to visualize geometric concepts? So, in order for us to get a better understanding of what we're supposed to either create, construct, identify, we're going to take a look at these three terms to start our section: points, lines, and planes. So if you look at a point has no dimension. When you visualize it or when you draw it, it's represented as a dot, and normally it gets labeled or denoted with a letter. So the example that they have to our right is point A. Next is you have a line. A line has one dimension. It's represented by two arrowheads. The two arrowheads established, that means it goes on and on until infinity in that direction in both uh, in both scenarios. The one thing that you have to keep in mind is 2 points are going to illustrate or be named by that specific line. If you look here, there's two different ways that you can name it. In this one here, they use the 2 points. You have A and you have B, so you could say that it's called line AB. And then you could either write line AB or you could write AB with the line with the two arrowheads above it. Or you could just call it line L. In this case, they just have it. Usually it's like in like a lowercase, and usually they use cursive when they do that. Is it necessary? Not always, but it's for the majority of it. Another thing that they add on is you can flip the points and it means the same thing. So line AB and line BA are the same line. So they just wanted you to keep that in mind. Next is a plane. So a plane says has two dimensions. It's represented by a shape. The shape that is most commonly used to draw for a plane is like a parallelogram. And even though it has the shape of a parallelogram, there is no essential stopping point. If it, I think it says in here, it says it extends without end. So it's going to go on and on in this direction, on and on in this direction, and this direction. But it's just giving you an illustration that it it's plain, yes, but there is no like edge that'll like fall off on it. It's just going to keep going on and on. There are two different ways that you can name a plane. It just can be denoted by a letter. In this case, they have it as plane M. The reason why I know that it is not a point is there's no dot there. Or you can use 3 points that are not on the same line. So like if you notice here, like if there was a point right here and this point wasn't there, you couldn't use that point. You'd have to make sure that there are 3 points that could not be created as a line. And we'll get into those definitions in a second. So part A here, so we have a diagram to the right. It says give two other names for line PQ and plane R. So let me give it a different color. Line PQ is right here. So giving it two other names, you can, it's got the N there, so I could say like, oh, this is line N. And you could also say that you could just flip the point and say this is line QP and then put the, so that's the two other names for PQ. For plane R, what you are going to essentially do is look at the points that are on the plane. Make sure that the 3 points that you choose um, do not create a line. So like I'm going to say like for one, it could be like plane. I'll pick V, S, and T. And then I'll just pick another one that's not the same. So it V, S, T. So let's just say V, P, T. All right. Those those 3 points would not make a line. So, and they're different from the points because I chose S instead of P. The next example here, it says name 3 points that are collinear. All right, so this is, you'll hear this definition quite a bit. Collinear means that it is all the points that are on a line. All right, so all the points that are on a line. So in this particular one, to name 3 points that are collinear, I would have to look at line M for this example because the points that are collinear would be point S, P, and T. Those 3 points are collinear. They're all on line M. And in this situation, they want you to name 4 points that are coplanar. So coplanar are points that are on the same plane. So what we have to do here is look at the points that are on the same plane. Looks like V is in the plane R, S is in plane R, P is in plane R, and T is in plane R. The only point that is not part of the plane is Q because it's on the outside of the plane. So we're going to say that this is going to be points V, S, P, and T. Those are the coplanar ones, and these ones are the collinear ones. Here it says use the diagram in example 1. It says give 2 other names for S, T. Name a point that is not coplanar with points Q, S, and T. So let me kind of go back. So they're looking at, try to erase this here. Let's look at line ST. So another name. I'm just going to use another point. I'll just use P and just call it, I'll call it line SP. So that's another name, or it says give 2 names. And, or I can use PT. So there you go. And this next one, it says name a point that is not coplanar with points Q, S, and T. So let's look at this. Q, S, and T. So this makes it a little bit more challenging to find or to be able to view it because there's no essential plane that is drawn on there. What you have to kind of do is imagine like taking a piece of paper and trying to place it on those points. So the point that is not coplanar is going to be point V. So I would say point V is going to be our point that is not coplanar, but so by definition, it's not part of the plane. Some other uh, concepts that kind of build off of points, lines, and planes are we got line segments. Line segments actually have an actual endpoint with respect to a line. If you look how you'd label a line segment, lines, if you notice, has like the arrowheads on the top. Line segments do not. So remember that there is an actual dimension in there, and usually it's denoted by a value, whether it's a number or a variable. A ray has a specific endpoint on one side, and then it goes on to infinity in one direction. The one thing that you have to keep in mind is you have to label these rays correctly, where the first point is the endpoint. So ray AB would be with this drawing, and ray BA would line up with this drawing. The last concept that we have here charted talks about opposite rays. So it's looking at point C. Point C lies between line AB, which means that uh, CA, ray CA, and ray CB are considered to be opposite rays. Okay, so from that, let's look at this diagram here. It says give another name for line segment GH. So this is line segment because there's no arrowheads. So all I'm going to do is just flip it around. So it's just going to be line segment HG. In part B, it says name all rays with endpoint J. Just which of these rays are opposite rays? So I can say, so this is where point J is. So all of, it says all. So looks like I'm going to start off here. So it looks like I got ray JG. I have ray JF. I have ray JE. And finally I have ray JH. So with that, they also wanted to know which ones are the opposite rays. So what we can conclude is JG and JH. So I could say that ray JG and ray JH are opposite rays. And I could also say that JE and JF are also opposite rays. So here it says Looking at this diagram to the right, give another name for line segment KL. Again, you're just flipping it. It's going to be line segment LK. On the bottom, it says R ray KP and PK the same ray. The answer is no. All right, the reason for that is because they have different endpoints. Here, they're asking is ray NP and NM, are they the same ray? So NP is right here, NM is right here. The question is yes, because by definition of array, you have the endpoint, they have the same endpoint N, and the other endpoint, doesn't matter where it's located, that ray goes on and on to infinity. So there's no ending point with P with respect to P and M. To point P or point M. All right, so here they want us to do some drawings. Again, I'm not going to grade your artwork. Um, I'm not saying that mine's going to be spectacular either. So what I'm asking you to do is do your best. So here it says for part A, they want us to sketch a plane and a line that is in the plane. So part A, anytime you're looking at a plane, you're going to draw it as a parallelogram. So I'm going to do so like this. And to establish that it is in the plane, all you got to do is make a line and kind of draw it on, kind of on top of the plane. Next, part B, they want you to sketch a plane and a line that does not intersect the plane. So you can do something like this. So I got my plane and that's pretty good. And here's my line. So sketching a line, a plane and a line that does not intersect the plane. So there you go. You could make an argument that they're perpendicular. If we get into more, you could say something like this. This is like a sign that shows that they're parallel, so that means they don't intersect. In this one here, it says sketch a plane and a line that intersects a plane at a point. So I have my plane, I have my line, and usually if you want to like show like hidden lines, so this is the point where it's intersecting, excuse me. And just here, finally, I think this is the last one. Yeah, I'll make it this will be the last one. Here it says they want us to sketch two planes that intersect in a line. All right, so basically you got two intersecting planes. So I'm gonna make my drawing here of one plane, and then I'll make my drawing of the other one. So I'll get my all right, so if you notice, this is the line that intersects these two planes. So like this would be like plane A, this would be plane B. They intersect when we can even give these two endpoints. We can call this like point X and Y. So they would both be intersected at line segment or line XY. And that is being able to look at points, lines, and planes. Hope this helps. Till next time.